The viral narrative claims Americans are turning against artificial intelligence because they fear rogue algorithms or ethical violations. This is a misdiagnosis of the actual crisis. Public anger isn't about chatbots, it's about the physical reality that data centers are consuming local power grids and water supplies at rates previously unseen in industrial history. The backlash is a visceral reaction to blackouts, rising energy costs, and the displacement of farmland for server farms. We need to shift the conversation from software ethics to hardware physics. AI cannot scale without solving an engineering crisis involving gigawatts of power, millions of gallons of water, and specialized chip fabrication capacity that simply doesn't exist yet at the required speed. The viral headlines suggest a cultural rejection of technology based on moral grounds. But look closer at where these protests are happening. They aren't in boardrooms debating algorithms, they are in neighborhoods facing flickering streetlights and rising utility bills. The anti-AI sentiment is not a philosophical stance against code, but a practical response to resource scarcity. As tech executives secure billions of dollars for infrastructure expansion, the local impact creates tangible friction that software ethics cannot resolve. When you hear about communities resisting new facilities, they are not protesting data streams, they are protesting physics. The barrier to future AI is no longer better models or faster code. It is a lack of new power plants and water treatment facilities required to keep existing ones running. To understand the scale, we must dismantle the metaphor of the cloud. Artificial intelligence does not live in a nebulous ether. It lives on heavy steel boxes requiring massive amounts of electricity and fresh water for cooling. In 2023 alone, United States data center consumption reached 176 terawatt-hours. That figure is roughly equaling the total annual usage of Ireland as a nation. By 2028, without major infrastructure overhauls, this demand is projected to double or triple again. A single modern AI hyperscale facility consumes as much power as 100,000 homes, compared to just 10,000 to 25,000 for a conventional cloud server. This exponential spike turns local grids into the primary bottleneck for expansion. The grid cannot simply absorb more load without significant engineering intervention because the physical capacity of transmission lines and substations is finite. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This leads us directly to the water cooling paradox that drives much of the public friction. Contrary to the digital nature we imagine, AI requires massive physical cooling systems to prevent overheating during continuous high-load operations. To dissipate heat from dense processor arrays, facilities require fresh water in staggering quantities. Google consumed 5.6 billion gallons of fresh water in 2022 alone, representing a 20% year-over-year increase. Microsoft's usage spiked by 34% between 2021 and 2022 to reach over 6 billion liters annually. This volume is equivalent to over 2,500 Olympic-sized swimming pools or the annual potable water needs of nearly 3 million people in developing nations. When local communities see their river levels drop or wells dry up, they are not seeing a software update. They are seeing an industrial thirst that outpaces natural replenishment cycles. Beyond energy and water, we face a critical lag in chip fabrication capacity. The specialized semiconductor chips required for neural networks are finite in production speed. While the projected market value of AI is expanding from $200 billion to $1.8 trillion by 2030, the physical manufacturing infrastructure cannot match this trajectory without significant delays or engineering breakthroughs. Even if we had infinite power and water today, we do not have enough fabs built yet to produce the necessary processors at scale. This creates a supply chain bottleneck where demand for compute outstrips the ability of foundries like TSMC or ASML to deliver finished hardware. The race is no longer about who writes better code. It is about who can build more chips faster without collapsing their local energy grids in the process. The result of these physical constraints is a visible crisis where expansion hits a hard wall. Local grids hosting these facilities are approaching capacity limits that mirror national constraints, forcing a desperate race for new transmission corridors through often resistant rural areas. Major tech firms are covering hundreds of acres with impermeable steel and concrete to house servers, displacing farmland and nature in the process. This physical footprint creates immediate displacement costs that software improvements cannot offset. The anti-AI movement is essentially a grassroots engineering critique. We have built a system that requires resources faster than our society can supply them safely or sustainably. The solution isn't banning AI, it's building new power grids, developing better cooling liquids, and expanding chip fabrication capacity. We need breakthroughs in grid management to handle the load without blackouts, liquid immersion technologies that reduce water usage by orders of magnitude, and advanced packaging capabilities that squeeze more performance out of every wafer produced. This is a hardware problem requiring engineering ingenuity rather than just policy debate on chatbot behavior. Until we solve for power density and thermal efficiency at an industrial scale, the expansion will remain constrained by the physical world's limits. The future of artificial intelligence depends less on neural network architecture and more on our ability to build the factories that make it possible. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.